Hi, so today we are going to explain about heat exchangers, plate heat exchanger and air-cooled heat exchanger. This topic will be presented by Siti Nozulaini, Muhammad Najmi and Muhammad Nursikri from UITM Shah Alam. So there are two types of heat exchangers we are going to cover, which is plate heat exchangers and also air-cooled heat exchanger. So let's dive into both topics. Topic 1. Plate heat exchangers. Plate heat exchangers is a type of heat exchangers that uses metal plates to transfer heat between two fluids. The flow of the substance it to be heated and cooled takes place between alternating plates, allowing heat to transfer through the metal plates. Topic 1.2. Parts and its function. 1. Frame. Frame is made out of thick steel pressure-retaining parts. The fixed cover and the movable cover. The carrying bar and guide bar act as a carrier and guide to both the plates and the movable cover. Second, plate. The heat exchanger plates which make up the heat transfer surface are clamped between two plates of steel with the use of the tightening bolts. The heat exchanger construction allows a plate heat exchanger to be easily opened and inspection for cleaning. 3. Gasket. Each plate has a gasket that produces a sealing and channel system through the entire plate pack in which the two heat exchanging media flow in a counter-current direction. The circular portion of the gasket stops the fluid from going across the heat transfer plate and sends it to the next open channel. The remaining portion of filled gasket directs the opposing fluid across the heat transfer surface. 4. Flow arrangement. The heat transfer plates with gasket are arranged in an alternating pattern of left-hand flow and right-hand flow to direct the fluids in an opposing direction within the heat exchanger. The complete assembly of all the plates and gasket is called the plate pack.
Okay, next, classification of plate heat exchanger. There are three types, which is plate and frame heat exchanger, brace plate heat exchanger, and welded plate heat exchanger. Plate and frame heat exchanger. Plate create a frame where the plates are pressed with headers and tie bars, and the seal is guaranteed by gasket. Gasket also serve to direct the flow of the fluids and are placed along the groove of the edge of the plates. Gasket available as butyl or silicon rubber. Operation limit. Temperature between 80 degrees and 2000 degrees. Pressure up to 25 bar and flow rate up to 5000 m3 per hour. Brace plate heat exchanger. No header, tie, bars or sealing gasket. More compact, lighter and less bulky. Bracing material carries out the function both of the gaskets and the frame. It's impossible to clean. The only way to clean is by applying chemicals. Operation limit. Temperatures between -195 degrees Celsius to 200 degrees Celsius. Pressure up to 30 bar. Welded plate heat exchangers. Plates welded together to increase pressure and temperature limits. Material used are stainless steel and nickel-based alloy. Also can be made from copper, titanium or graphite. Operating limits. Temperature depends on the material. Pressure can tolerate more than 60 bar. Next is fouling. Particulate fouling or silting, which is solid particles are deposited on the heat transfer surface. Next, biological fouling. Deposition and growth of organisms on surface chemical reaction. Fouling arises from the reaction between a constituent in the process fluid. Lastly, freezing or solidification fouling occurs when the temperature of a fluid passing through a heat exchanger becomes too low. Next is advantage and limitation. Advantage: lightweight, because of the reduced liquid volume space and less surface area for a given application. Next, high viscosity application, because the plate heat exchanger induces turbulence at low fluid velocity, saves space and servicing time. The plate heat exchanger fits into an area 1/5 to 1/2 of required space. Lower liquid volume, since the gap between the heat transfer plate is relatively small. Lower cost and quick process control. Limitation. The maximum allowable working pressure is also limited by the frame strength and the plate deformation resistance. Commonly state limit have been 150 degrees Celsius and 300 psi. Due to the narrow gap between the plates, high liquid rate will involve excessive pressure drop, thus limiting the capacity. Large difference in fluid flow rates of two streams cannot be handled. The gaskets cannot handle corrosive or aggressive media. Gasket always increase the leakage risk. The standard plate heat exchangers cannot handle particulates that are larger than 0.5 mm.
We move to next topic. air-cooled heat exchanger. The operating principle of this heat exchanger is straightforward. The hot process fluid enter one end of the air-cooled heat exchanger and flow through the tube, while ambient air flow over and between the tube, which typically have thoroughly thin surfaces. Air-cooled heat exchanger, sometimes called air coolers, are used in refineries, petrochemical plant, gas treating plant, compressor station, power plant, and other facilities. Air-cooled heat exchanger also used for process cooling and condensing. We move to topic 2.1, type of air-cooled heat exchangers. There are two types of air-cooled heat exchangers. The first one is induced draft. The fan is located above the process bundle and air is pulled or induced through the tubes. Second one, forced draft. The fan is located below the process bundle and air is forced through the tube. The advantages of induced draft: 1. Better distribution of air across the bundle. Second, less possibilities of hot effluent air recirculating into the intake. Third, better process control and stability. Fourth, increased capacity in the fan off or fan failure condition. Limitation: the first one is possibly higher horsepower requirement. Second, effluent air temperature should be limited to 220 Fahrenheit. If exceed 350 Fahrenheit, forced draft design should be considered. The third one, fans are less accessible for maintenance. And lastly, plenum must be removed to replace bundles. Next, advantages for forced draft: possibly lower horsepower requirement, better accessibility of fans and upper bearing for maintenance. Last, better accessibility of bundles for replacement. Next, limitation of forced draft. The first one is less uniform distribution of air over the bundle. Second, increased possibility of hot air recirculation. Third, low natural draft capability of fan failure. Fourth, complete exposure of the fin tubes. And lastly, advantages of induced draft design outweigh the disadvantages. We move to the next subtopic, a subset of the forced draft design in the winterized unit. A forced draft air-cooled heat exchanger is outfitted with one or more methods. For example, air outlet levers, fan equipped with variable frequency drive, hot air circulation system to control the temperature of the process fluid leaving the heat exchanger. This type of unit is typically found in colder climates, but it is also used in hot climate such as the US Gulf Coast for process fluid with high viscosity and high pour point. Next, a typical air-cooled heat exchanger has the following component. 1. One of more bundles of heat transfer surface consisting of thin or bare tubes connected by headers. Second, an air moving device such as an axial flow fan, blower or stack. Third, a support structure high enough to allow air to enter beneath the air-cooled heat exchanger at a reasonable flow rate. Fourth, optional header and fan maintenance walkways with ladders to grade. 5. Optional louvers for process outlet temperature control. 6. Optional recirculation duct and chambers for protection against freezing or solidification of high pour point fluid in cold weather. Last one, optional variable pitch fan hub or variable frequency drive for temperature control and power saving. One of main component is fin, which attach to the tube in the number of ways by an extrusion process in which the fin are extruded from the wall of an aluminum tube that is integrally bonded to the base tube for the full length by helically wrapping a strip of aluminum to embed it in a pre-cut helical groove and then pinning back the edges of the groove against the base of fin to tightly secure it by wrapping on an aluminum strip that is footed at the base as it is wrapped on the tube. The last topic, falling, refers to the uniform accumulation of suspended particles on a surface. it does not involve any sort of reaction and settlement. It's temporary. The external surface of the tube starts to fall as the result of environmental dust. Compressed air pressure up to 600 psi is used for maintenance.